Okay, so in this video, I am going to talk about the inventory decision model for the company Promus Corp. So in this model, you have a few deterministic parameters and one random parameters. So the deterministic parameters are gross profit per unit. So if they are able to sell one router, then they can make $50. Holding cost parameter, again, this is per unit, which means that if in a period they are not able to sell their full stock, then they need somebody to keep their leftover stock, and it's going to cost them $15 per unit. And then they also have the shortage cost per unit, which is $30 per unit, which is basically if their demand is higher than what they are stocking, that means that they are leaving some customers empty-handed, and that is their shortage cost, right? So those customers might not come back to them again, and that's kind of determining the shortage cost for them. So if they lose one demand or one customer, then the shortage cost that they will incur is $30. Now the demand is going to be random, and we need to generate the demand. What we know is that the demand follows a normal distribution with a mean 100 and a standard deviation 2. Okay? So we are going to use, we know how to generate a normal random variable. And the way to generate is to use the norm in function, norm in right here. And then it asks for a probability. So because it's a random variable, the probability is going to be generated by the random number. And this rand function gives you a number between 0 to 1 randomly. Then it's going to take the mean, which is right here, and then it's going to take the standard deviation, which is right here. Okay. Now, one thing you need to do while drawing a normal distribution for demand is that you need to make sure that that your demand is not negative. Right? So if you think about a normal distribution, the range of a normal distribution can go from positive infinity to negative, which means that ideally this number can be a negative number, but you don't want that, right? Because a negative demand doesn't mean anything. So to prevent that, what you're going to do is you are going to use max function, max, and then you're going to take the maximum of 0 and this normal or random variable. Right. So what that will do is that if your normal norm-in function generates a negative number, then instead of taking the negative number, you're going to say your demand is 0. Right. So every time it generates a negative number, you're going to say your demand is 0 and not a negative number, because a negative demand doesn't mean anything. All right. So that's all for the random number generation part for this problem, because everything else is deterministic. Now I have created the model for you. So you have the sales, gross profit, holding cost, shortage cost, and net profit. So in class, we went over the detail of how these formulas are, how did I write this formula. So I'm gonna not go over that in the video. But essentially, here are your two possible replenishment levels, and you are trying to decide which one is better for this company, right? So the questions that you're trying to answer is, should they stock 90 units or should they stock 110 units, right? So if they stock 90 units, then here is their net profit. And if they stock 110 units, here is their net profit. Now, of course, this depends on the demand, right? And because demand is random, every time demand changes, this net profit changes. So what we're going to do is we are going to do 1,000 simulations where we generate the demand 1,000 times, and we generate this profit 1,000 times, right? And then we take a look at what is more probable to happen and what does the histogram look like. So we are going to try, we're going to start our simulation just like we do all the time. So you're going to start writing your number 1 to 1,000 first under simulation trial. And you want to start with 1 and then go to home, right? And then fill. And then you're going to go to series. So in series, because you're creating the random numbers, the simulation trials, the number 1 to 1,000 in your column, which is why you're going to select columns. And your step value is going to be 1 and stop value is going to be 1,000. Okay. So if you did everything correctly, that should give you the number 1 to 1000 under simulation trial. Once you have that, the next step is to link your random inputs and outputs. So your only random input is your demand, right? So I'm going to link my demand to your formula right there. And then the profit formula right here is for replenishment level 110. And then I'm going to link this to replenishment level, profit for replenishment level 90. Once you have all of that done, then you are going to select the whole table. And by the whole table, I mean all of your simulation trials, right? So you first want to select the first row and then press either Control Shift or Enter if you, Control Shift and down arrow if you're using Windows, and Command Shift and down arrow if you're using Mac. There you go. And then you're going to go to your data right here. And then under what if analysis, you're going to choose data table. Once you have this pop-up box, your row input cell should be kept blank. And your column input cell should be any cell that is not occupied, right? So that does not have anything written on it. And that is outside of this table. So anything, basically. That's about it. So once you have that, do that, you should be having your table filled. And just to be consistent, I'm going to make all of this $sign. I think some of them aren't, some of them aren't. So I'm just gonna select all of them and then go to home and choose currency. Okay. All right. So now we have 1000 simulation of profit if the replenishment level is 110. And the same for profit if the replenishment level is 90. So what I'm going to do is I'm going to create a profit difference column so that I can analyze the difference of these profits. Profit difference. And my formula is going to be profit for Q equals to 110 minus profit for Q equals to 90. Okay. And the formula is, of course, your profit for 110 minus the profit for 90. So, for example, in this instance, what happened is you are getting $4,075.84 if you replenish 110 units. However, if you replenish 90 units, then you're going to get a $300 more. So in this instance, replenishing $90 looks better than replenishing $110 because there will be a higher profit, right? So in other words, if your difference is negative, that means that replenishing $90 is better, just based on this formula, because you're doing profit for 110 minus profit for 90. And if this difference is positive, then $110 is better. So let's see what the whole table looks like. So I'm going to go ahead and click on that so that I have the whole table. So now it changes, right? As you can notice that some of the numbers are negative and some of the numbers are positive, right? So it is not very clear just looking at these numbers which profit, which replenishment level is going to give you a higher profit. All right. So to do that, we are going to do some analysis, and that's where the summary statistics are going to come into play. So the first thing in summary statistics that we're doing is the count. The count basically means that how many times did you do your simulation, right? In this case, we did 1000, so I'm going to write the number 1. What is the minimum difference? I'm just going to use the min function, and I'm going to use the function on the profit difference because we are analyzing the profit difference, right? So Control Shift and down, or Command Shift and down. Max. Again, Control Shift down. Then mean difference, you're going to use the average function for that. And then standard deviation, you're going to use stdev.s function for that. And finally, I want to calculate the probability that this difference is greater than 0, right? Which also means this is the probability that replenishing 110 units would be better than replenishing 90 units, right? So to the probability, I'm going to do count if, and then you're counting if this this cell right here is greater than 0 or not, right? So you're counting the criteria. You're going to select all the whole column, and then to write your criteria, you're going to use a quotation. And because you're calculating the difference greater than 0, your criteria is going to be greater than 0. And end your quotation and end your parentheses, and then you're going to divide that by 1000 just because you did 1000 simulation. If you do 100 simulation, you would divide it by 100. Okay? Depending on how many simulations you do, this number is going to change. All right. So that's the probability right there. So 0.6 probability 6. Sorry, with probability 0.6 or with a chance 64.3%, this profit difference is positive, right? So which means that there's a more than 60% chance that replenishing 110 units will give you a more profit than what if you replenish 90 units. So that means that just based on this probability, you could say that replenishing 110 units will be better than replenishing 90 units. You could also look at the average difference. You see that the average difference is positive, right? Which again means that 110 is better than 90. Right? So the profit for 110 would be higher than the profit for 90. However, the last thing that we are going to calculate is a 90% confidence interval around this mean difference. Right? So right now we have the mean difference, but we don't know how sure we are about this mean difference, right? Because it's in simulation, again, every time you enter a cell or enter a formula, everything changes, right? So because it's a random parameter, what we need to kind of understand and what is the 95% confidence interval on this mean difference, because that will tell us our confidence in this difference, in this number right here, right? So to calculate that, this is the formula. You start with, so because we are looking at an interval, the interval is going to have a lower bound and an upper bound. We can start with the lower bound. It's going to be the mean difference minus, and then we are going to use the function called confidence.t, and it's asking for an alpha. So the alpha is going to be 0.05 because I'm looking at a 95% confidence interval. If you're looking at a 99% confidence interval, this alpha is going to be 0.0. And then it's asking for the standard deviation. And then the size, and the size is how many simulations you're doing, or the sample size, which is 1000. That's your lower bound, and your upper bound is going to be, again, the mean difference plus confidence.t, alpha 0.05, then standard deviation, then the size. Okay. So basically, it tells you that you are 95% confident that the average profit difference would be between 622 to 722. Okay? And that's a pretty good number, which means that if you're looking at your average difference and the probability that difference is greater than 0, both tells you the same conclusion that you should probably stock 110 units instead of 90. However, what we still don't know is the whole risk profile, right? So we still don't know what is the individual chances of each of this profit difference. So to do that, we need to do a risk analysis. And by risk analysis, I mean we need to create a histogram. So to create the histogram, we're going to first start working on our bins and then the frequency. So to start your bin, you are going to start with the minimum difference. And then in this case, so if I'm not giving you a bin width, that means you're free to choose, but just be smart about choosing the bin width, right? So in this case, for example, it could go from your minimum difference is negative 300 and your maximum difference is 1600. Which means that if you do a bin width of 1, that's probably a really bad idea. But you could do like a bin width. So you have to cover numbers between negative $300 to positive $1,600. So probably a bin width of 200 will be good, or 100 or 300. These are good bin widths. Okay, I'm just gonna do let's say 200 plus 200, and then I'm going to drag it down until I have passed a little bit more than the max difference. Okay, looks pretty good. Now I'm going to use my frequency formula and your data array, comma, and your bin array. Okay, there you go. And let's make our histogram. I'm gonna select everything and then go to insert. And then go to 2D column, and that's my chart. And I'm gonna name it as profit difference. So I'm gonna name it as profit for Q equals to 1110 minus profit for Q equals to 90. And finally, I need to change the horizontal axis. So I'm going to go to select data. And right here, I'm going to edit. And I'm going to tell Excel that these are my bins, not 1, 2, 3, 4. Okay. And there you go. So this is your histogram. What the histogram shows is basically you have a high chance of getting a negative 100 profit difference. You also have a high chance of getting 1700 profit difference. So there is a high chance that 90 would be a better, and there is a high chance that 1700, so 110 will be better, and not only it will be better, it will be $1,700 better, right? So you can earn up to 1,700 more profit by choosing replenishment level 110, right? So again, it's up to you what you would do, but this is what the graph tells you, and the graph tells you that the decision is not very conclusive, right? So you still will have a high chance that with $90 profit, you are probably gonna end up with lower profit than you would under 110. But again, you could make your decision just based on the average difference and the probability of your difference is greater than 0. And that would be to choose 110. Okay. So whenever you answer such question, just tell me what you're thinking, and based on that, give me a suggestion that you would be giving as a manager to the manager.